Welcome to the Introduction to Ecology. This is lecture 10, believe it or not. A little pop quiz to start us off in this lecture. This is a poster that comes from the Natural Resources Conservation Service, and it lists what has happened in the time it took to form 1 inch of soil. And that's not 1 inch of soil anywhere, but it's a very interesting poster. Now you cannot probably read that on this screen. No, more likely you can't. But this is linked in our news section of the course D2L page. So this is a quiz. Drop this answers to this pop quiz in the drop box. 3 things that this poster lists that happened within the time it took to form 1 inch of soil by 7 a.m. on the last day of Unit 3. You'll have to see the syllabus for that date because, well, this stretches over several different courses. Anyway, have fun with that. This is actually extra credit for your unit tests, 10 points worth, so that's like a letter grade. It's worth doing. Population challenge, soil and agriculture. Related. So, this is an excellent view here we have of worms and fungi. That's not going to show up at all. You know, I keep playing with this and trying to get the right colors. There we go. Worms, fungi, and the roots. Oh, look at my little face. Didn't mean to do that. Kind of looks sort of like Mickey Mouse. But anyway, that's what the basis of ag is. Moving beyond that, soil is more than the foundation for what we eat. Far more than that, or what we build on, because all of our buildings, of course, based on soil. This is Thomas Jefferson. Civilization itself rests upon the soil. Obviously, some more quotes. This is Franklin Delano Roosevelt. The nation that destroys the soil destroys itself. And our third quote is from Aldo Leopold, who was the father of conservation. 2 spiritual dangers in not owning a farm. One is the danger that breakfast comes from the grocery, or in our case, McDonald's. The other is that heat comes from the furnace, and indeed heat comes from the fuel we put into the furnace, often wood, in this case. So let's look at intensive farming. You can have monocultures, like this. That is one long expanse of, I guess, wheat. So monocultures versus the term intercropping. So what do monocultures have? Monocultures, they feed large numbers of people, as in we have 7.43 billion people, or whatever that number was we came up with a couple lectures back. What about insects? There's nothing really to stop insects from coming and ravaging all of this, although they've changed a lot of practices so that you have to have trees. It might break things up a little bit, but that's a different story. And what about drought? How this one, you have to water this, irrigate. How do you irrigate something that large? Wow, that's a lot of water. And then diseases. If you have only one crop, disease can become rampant. Another view of it is this thing called intercropping. Intercropping, you have a variety of crops planted next to each other. You have corn, in this case maize, and then a row of soybeans, and then a row of oats. And those 3 crops, this is actually an actual picture, believe it or not. It looks like a painting, but it's not. So, intercropping increases productivity for a variety of reasons. We'll get into more on that later when we talk about soil types. Protects the crops from drought because you have a variety of crops and you can actually irrigate smaller areas than that. Less pesticides are needed because a bug that's going to come in and, let's say, attack the corn crop is not going to come in. It's not going to be the same bug that's going to get the soybeans or the oats. So it's a better way of doing things. Now, you can't drive those big honking machines all the way across a field like this. That's very true. But in terms of these other benefits, it's very beneficial. So, it may be all about the soil. Hunger, malnutrition, food supplies, we're going to go into some fairly serious stuff, and the environment, how those things all fit together. declining food supplies in certain parts of the world, and feeding people versus protecting the planet. That is a balance that we are still struggling to strike. We need to feed people, and we need to protect people and protect the planet. Part of that stewardship thing we've been talking about. Soils are the foundation for sustaining agriculture, sustainable agriculture. We'll talk more about how soil is formed. We talked a little bit about this in an earlier lecture. The history of agriculture. Go into a few more details about how ag developed. I know we talked about the Fertile Crescent, but it's going to be, we're going to do just a little more worldwide view. Soil as a system, an ecosystem. How long does it take to form an inch of soil? Well, that depends upon where you are on the planet and what other sorts of conditions are happening. A little bit about soil chemistry. We won't get into that very much, but it's complex. I think that's the point of talking about soil chemistry in this context. Soil conservation. Specifically the Soil Conservation Service, which is a federal agency. It's changed its name now. We'll talk about that in a minute. The Dust Bowl and how we are still overcoming it. And, finally, I would say sustainable ag, but that's for next time. I left that on here, just have something to look forward to. So, hunger, malnutrition, food supplies. Feeding people versus protecting the planet. Well, 16% of people are undernourished. And this is a shocking, really sad image. These two boys are in various ways undernourished. One of them has a lack of natural proteins. I believe that this is Kwashiorkor here. He can have all the other food he wants, but he has the wrong kind of proteins. And then Marushnus, I don't think I said that name right at all, basically does not have enough food to eat. No simple answers. There are no simple answers to these problems. But we have lots of food in this country. Why are people still starving? Well, because we have a hard time getting out there. There's a lot of political things going on here too. We're not going to get into that in this lecture or in this class. So, out of that 7.453 billion people, more than 2 billion suffer from undernutrition, and this is the subcontinent of India. And there are certain parts of India where this malnutrition is really endemic. In those portions, this is the portions of underweight children in 2004 and 2005. And the darker the color, the higher the percentage of underweight children. Those orange numbers are between 61 and 95% of the children are underweight. They may receive enough calories and protein, just like the child in the previous slide, but not the right kind of essential nutrients. Calories and protein don't make you healthy, particularly when you're growing. Children at this age are much more susceptible to disease. 80%, this is a real number, 80% of the brain's growth occurs before age 2. That's when we most need to have that good nutrition. So, a little more on that. There are several non-nutritional issues going on, though, in terms of mortality, infant mortality. That's what this is an image of. Infant deaths per 1,000 births in 2009. All these red areas are 50 and above infant deaths per 1,000 born. And worldwide, I believe the global number is about 20. In this country, it's about 10, which is a lot, but it's still not compared to this. Environmental health. We will talk later about the Flint water crisis. I'm not equating the Flint water crisis to what goes on in India, but it is where we have not taken care of the environment, where we should be taking care of the environment. It is a symptom, and we'll talk a bit more about that in a later lecture. Adequate sanitation is lacking in many of these areas, and that affects the development of children. Common preventable diseases kill millions of children in the developing world. Diarrhea, things that we take for granted simply kill, diseases we take for granted we can cure, simply kill a lot of these children. So some basic problems of environmental problems, basic environmental problems, causes, spit it out. Population growth. There are too many of us, really, and our population continues to grow. The second one is the fact that we're very wasteful. We will cut down trees just for the sake of having paper. You notice in this class we don't use any paper. Of course, we use a lot of other things. But I don't ever want to see any paper. That's kind of, well, go on. Poverty is another cause of environmental problems. Not that the people who are in poverty are causing the problems, but, well, we'll get to that in a later slide. If you're impoverished, your main concern is finding your next meal. It's not going to be, what am I going to, how am I going to entertain myself today, or how am I going to save the world today? It's how I'm going to feed my children today. And this goes back to that Flint water crisis idea. There's a failure to include the complete environmental costs of goods and services in the market prices. This is an example of redwood trees being turned into benches. Redwood trees are far more valuable than being used for furniture. But in the case of Flint, what happened was that in order to save a few dollars, the proper water treatment was not done for the sort of water that they had switched to. And it was done to save a few dimes. Literally, and now paying a big price for that. So failure to include the complete environmental costs, including the human environment, human health costs of goods and services in those market prices. Population growth is highest among the poor. Malnutrition, premature death, we saw that in India. Limited access to adequate sanitation facilities and clean water. Not so much in this country, though there are parts of this country certainly who suffer from that. This is at one of those statistics. 1/2 of the world's population, 3 billion people, lives on less than $2 per day. Most spend their time just surviving. The affluent throughout the world can make informed environmental decisions, can actually support scientific research in how to make better scientific decisions, identify problems and multiple solutions, consider human values, and work together to solve those environmental problems. We'll go back to our roots. Back when we were hunters and gatherers, we were cooperative societies, although we did probably fight each other, but within our society we cooperated. First thing we do, well, we need to feed those in need, and then the rest of society can grow from that once we've taken care of the most needy among us. So, soils. Changing the subject, lightening it up just a little bit. Foundation for sustainable agriculture. We're going to look at the history of agriculture once again. Soil and the foundation for agriculture, which we haven't really talked much about yet. Soil is an ecosystem. How long does it take to form an inch of soil? And that depends upon where you are. Soil chemistry, briefly, we won't get into that very much, and soil conservation, the Dust Bowl, and how we're still overcoming it. So, for 200,000 years, we're hunter-gatherers. Why the switch? Why were we happy out hunting mammoths with spears or big sticks? 10,000 years ago, approximately, the glaciers had begun to retreat. Not that they hadn't done that before. Accidental planting became trial and error. So you did something by accident, and then you realized, oh, well, let's try that. That worked. Let's try something else. There is archaeological evidence showing that 10,000 years ago is when we actually started settling down and trying to plant things. Simultaneously and independently across the globe, this happened. And, well, what was one common denominator? Well, that common trait is the fact that all of these, I guess, agricultural innovations are tied back to having fertile soil. It wasn't just in the Fertile Crescent. We talked about this in the Middle East, Mesoamerica, and said Mexico, also in parts of North America. Maize and squash were developed. Really, we came up with basically the husbandry to come up with that. Potatoes come from Peru, the Andes of South America. And China developed rice. And say developed, we did. The Sahel, which is a region of Africa south of the Sahara, sub-Saharan Africa, if you will, is where sorghum comes from. You may not know sorghum, but it is commonly used today as a supplement for cattle feed. We use it in many, many products. It is a fundamental source of protein and, well, sugar. I remember growing up having sorghum molasses, but it is used for an abundant, a tremendous number of things. And of course, coffee. Where would we be without our morning coffee, or our afternoon coffee, or our evening coffee in some cases? Without Ethiopia, well, growing crops ended, for most, that nomadic lifestyle. When we started settling down growing crops, you can't just go wandering across the plains hunting for bison. It became a positive feedback loop. We talked about those in an earlier lecture, things that seem to continue to not spiral out of control so much, but, anyway, more ag led to more people because we could feed ourselves better, we were settled down, we were safe. Positive feedback loop. Talked about that last time. So a little more detail on this, the map here. You have maize, you have sorghum, you have rice. Let's get closer. All right, so Mesoamerica, maize and squash. The Andes had potatoes. We'll talk about the potato famine in Ireland is related to the fact that we didn't diversify our potato crop very much. They diversified just fine in that part of the world, but by 1840, this is 10,000 years after we started developing potatoes, we were still relying on them. This is kind of the eastern hemisphere side of things. Rice, right there from China. Sorghum comes from this sub-Saharan African region, right there on that part of the map. And we didn't have a coffee bean to stick on there and show you where it comes from in Ethiopia. China rice, Sahel, sorghum. Growing crops ended nomadic life. We ended up, we had to take care of the cows. And somebody's got to herd those cows. Once again, positive feedback loop. Go forward. No, don't go backwards. There we go. Positive feedback loop. More ag, more people. That allowed development of work not tied to the land. So you have the overseer over here. It's a real thing. And until recently, 20th century, 100 years ago, 60 years ago, most people were still tied to the land, still farming. That was the primary way of earning a living. Of course, what's our population done since that time? It's exploded. Let's look at soils. We've looked at soils before. This is a rather complex view of soils. There's metal down there, zinc, that's sodium, there's cobalt, copper. All that, it's toxic, right? No, that's actually, those are fundamental nutrients. Soils contain organic matter, and this stuff in between is organic matter, with nutrients. The structure allowing plants, roots to penetrate deeply. Without those micropores, we'll see that in a later slide, it's very important that structure be present, because that's what the roots of plants are based on. Those roots support the plants. If they can't go deep, then the plants tend to not be as healthy in certain places. Basically, plants can then take in these dissolved nutrients, believe it or not, those are dissolved, and water. Grazing animals. Quite often, grasses depend upon being eaten, believe it or not. They have to, a pasture is healthier if it is grazed. Healthier in terms of nutrient balance and healthier in terms of plant growth, because it basically crops off the slower growing portions of the plant. Grass grows from the base. And you see this in the savanna in particular, that it also, after a ungulate of some sort of grazing on wildebeest, use a wildebeest for example, they come along and they eat the grass and then they fertilize the grass. They move that stuff around. It's very healthy. Healthy soil will last for decades or more unless we abuse it. Don't abuse the soil. So, ecosystems of soil. Looking at this in a bit more care, way down at the bottom here, there are burrowing animals. You can maybe be able to make out fungi, the mushrooms and things like that are throughout the soil profile. There are microbes down there, worms, roots, insects, all kinds of things. Soil is very much alive, very healthy. So, not all the soil ecosystem is right here on the top. The soil ecosystem relies very, very much upon what's going on in the subsoil because the roots have to penetrate down there to be healthy. And the weathered rock, of course, is an important part of it. Topsoil and subsoil are very, very important too. Two most common types of, now mycorrhizae is a type of fungi. Those mycorrhizae actually grow in conjunction with roots. Now, mutualism, where both the plant and, well, two different organisms, in this case a plant and a fungus, benefit. That's mutualistic. So we have AMF, arbuscular mycorrhizal fungi. They produce these arbuscules, sites of exchange between the plants and the fungi. I have a picture in just a second. And hyphae, fungal filaments that actually come out from the root itself. And then vesicles within the root that are energy storage organs. You will see that in a future slide. And then we have these ectomycorrhizae, ECM, if I can remember that acronym. I always forget that for some reason, but ectomycorrhizae forms a mantle. If you look at a root and it looks all fuzzy, likely most of that is because of ectomycorrhizal fungi, ECM. Increasing plant access to immobile nutrients and water, actually. That's the same thing that the arbuscular mycorrhizal fungi do also. So, water balance. Andropogon smithii is a type of blue stem grass, very common one. Plants with mycorrhizae do a much better job of maintaining the leaf water potential. If a plant wilts and its leaf water potential is poor or not good at all, and the presence of these mycorrhizae fungi greatly increase the ability of plants to take on blue stem grass, to take on water. So greater access to phosphorus, because that's what's actually in the soil profile. Develop in roots that are more efficient at extracting and conducting water. So these are ECM, ectomycorrhizal fungi. You see that fuzzy part. And this is arbuscular mycorrhizal fungi, AMF. Mycorrhizal fungi improve those water relations. See these little things shooting out of here. And then the improve water relations, provide more extensive contact with moisture in the rooting zone, all those good things. You can see the little vesicles inside the root there. And it's a mutualistic relationship. It's something that both the plant and the fungus benefit tremendously from. It takes a long time to form soil. It starts out with this parent material, this big rock. We're starting out with volcanic rock, igneous rock, sedimentary rock, metamorphic rock, however that rock is formed. Rock is very high in nutrients, because that's pretty much what rock is nutrients and minerals, and plants want to get at that stuff, but they can't penetrate this outer shell. Boom, they try to grow into it. But there are three processes: biological processes, physical processes, and chemical processes that all work together to, over time, break this big piece of rock. The big piece of rock, it's hard to get at. Get into these smaller pieces, and the biological processes actually dissolve some of that, the rock. They actually use acids to do that. Chemical weathering is another way. Rain is actually acidic. It has a slight acidic quality to it. And then the physical processes are things like, well, freeze and thaw cycles. You get the water inside, and physically it breaks that rock up. And as you get to smaller and smaller pieces, this is the same amount of rock, but it's been broken into smaller pieces, that suddenly the plant can get in between these pores, and you have a lot of soil formation from that. And there's a great increase in surface area. Did I already say all that? Physical processes first. Oh, I should have just run through this. Weathered rock, smaller pieces, particles from big particles. Remember, primary succession starts from bare rock, and this is the bare rock we're talking about. It takes a long time to do this. This is a part of the slow step in soil formation. So 5 main factors. This is actual soil, an actual photograph of soil. Actually a photograph of soil with a profile here in Florida. It's amazing, I found some. Climate is a major factor. There are parts of the world, and we'll talk about this later, not much later, where soil forms very slowly. You could imagine that those are areas that are likely very cold, or cooler at least, or where there's not an abundant amount of water. Organisms are very important for soil formation because you have to have things growing in these the top of it to help to continually break down the soil down below. Topography. If it's too steep, the soil won't form because the rock will just roll off. Or if it's too shallow, you have a hard time forming new soils. And what is the parent material the soil is formed from? A lot of this soil happens to come from, well, that happens to be a water hyacinth right there. I believe this is called Bahia grass. Those are all things that help form and maintain that soil. And then time. How long does it take? I wasn't done with that slide. Come back here. There we go. Time. How long does it take to actually form soil? Well, we'll see. It varies a great deal. Okay, first two of 5 main factors for soil formation. Climate. Soil forms much faster in warm, wet climates. Heat and moisture speed up those chemical and physical processes. Now, not too wet. Organisms, very important. Plants, decomposers, add that organic matter, and that speeds the formation of soils. Third is topography. Hills and valleys affect exposure to the elements, also influence how soil moves and erodes. What's the parent material made of? Its attributes influence the properties of the soil. And then time. I think this is the one that may be more surprising. Formation can take decades if you're in a warm, not too wet environment, subtropical particularly, and into the tropics because it's not too wet. It can take centuries in middle latitudes, for example the Great Plains, millennia if you go further north or south from there, or if you're in a very dry place. It takes a long time to form soil. This is a really complex slide. So this really goes in towards what exactly is involved in soil. There's a lot of stuff. It's just dirt. Well, it's not just dirt. You got to have the percent clay. Color makes a big difference in terms of soil chemistry. Texture. How well does the plant? If there's more clay in it, it's going to be very finely grained. Silt actually is not a bad thing. Sand is low in nutrients, but it provides micropores for plants. Structure. What is this soil made of? And all that chemistry comes into play in this. And finally, because this is so important, the actual balance of pH. pH will allow certain soils to release or hold on to the nutrients that they have. The lower the pH, the more, the less likely a soil is to hold on to its nutrients. Higher pH soils will hold on to nutrients better. So this is actually a storm drain, a flooded area where you can see water is just standing there, and we've got some soil erosion issues going on in this particular image. So soil conservation is critically important. And what causes the loss of soil? Well, in this case it looks like flooding is causing it. Human activities cause a lot of soil degradation. Whether it is don't do that. Come back here. Hit the wrong button. Apologize for that, but you get over it. Whether it is actually the let's use that one. Yeah. We think really that industry is a big part. You can't hardly see that little line there. Yeah, you can sort of see it. But do you think of industry as, wow, we're going out and killing the soil with bulldozers? Well, that's not really what's going on here. When we remove forests, which we do with bulldozers or chainsaws, that contributes 30% of the soil loss globally. Overgrazing, putting cattle on the land for too long, 35%. That's the majority, though it's a narrow majority, if you will. And ag itself, agricultural practices, like where this particular image was taken, is in a soybean field, a lot of soil is lost to that. And then fuel wood gathering. We talk about, I think we've talked about Haiti in the past in previous lectures. Fuel wood gathering accounts for 7%, although much of the slopes of Haiti have been denuded of soil, denuded of trees, and which would hold that soil in place because there's no other source for firewood. Talk about the Dust Bowl. There it is, blowing right in. This is an actual image. These clouds were 10,000 feet high, and that it's all dust being blown. I think this was in Kansas in the 1930s. So, the Great Plains wasn't always like this, and it isn't like this today. Sod and prairie grasses covered Sod is very important. Prairie grass is very important. Primarily what the Great Plains were made of to the turn of the 20th century. We came along and started cultivating it. Well, we went 1879, we had 12 million acres in cultivation. 50 years later, 1929, we suddenly had 100 million. Not suddenly, obviously, it developed over time. So what's that? Almost a tenfold increase in the number of acres. Settlers moved in with crops and livestock. Made a huge difference in terms of what's going on in the soils. They busted up that sod. Sod busters busted that sod. That busted sod then allowed the wind to come along and pick up the soil and blow it into huge clouds. Remove those native grasses because they weren't wheat. We started just having monocultures out there. Didn't account, and there are very severe droughts. It can go for 2 years and have no rain, almost no rain in these areas. And if you have a natural prairie, it can withstand it because it has this sod that locks that moisture in. Prairie grasses hold things down and they just hunker down, if you will. But if you have plowed up everything that's out there, it's far more likely that you are going to start having the wind pick up all that soil that's loose and carry it around like it did in this image and in this one. This is another amazing, somewhere in here, I think the barn is, base of it is right down there. Millions of tons topsoil eroded. Incredible dust storms traveled all the way to the Atlantic Ocean. Now we still have dust that travels all the way around the world. In Florida, we sometimes will get dust, believe it or not, from the Sahara Desert. This is a thing called Saharan air layer. We'll talk about later when we talk about global global weather. Some areas of the Great Plains lost as much as 4 inches of topsoil. Now, when I talk about Saharan air layer, that I'm not talking about the Dust Bowl. That's something that deserts do a lot of. The federal government did respond to this, believe it or not, in the 1930s. 1935, this is Franklin Delano Roosevelt's signature right there. It worked closely with local farmers after they formed this thing called the Soil Conservation Service. Developed conservation plans for individual farms. Big deal. It is a big deal. Still is happening. We're still working those conservation plans. And it wasn't just, well, a bunch of folks got together. Well, actually, you took soil scientists. And soil is a complex thing. And soil scientists, that's still a very important career. We need a lot of soil scientists because soil is still very important to us. Experts in forestry to try to restore some of these forests that we've cut down for a variety of reasons. This is the 1930s, 1935, remember that. Engineers to make sure that our designs are, sound technically. Don't just go out there and build something that's going to collapse. Economists, are we actually growing the crops that are going to benefit people? Well, that's a big question that only someone who has experience in economics can get at. And biologists, are these plants actually going to make it out here? Do we need a variety of plants? So that's how the SCS approached things from 1935 until, well, today. They're still doing it, still working today. Natural Resources Conservation Service. Partners, we have a local Highland Soil and Water Conservation District, which was formed in 1942 because, there weren't that many people here in 1935. I'm talking about in Highlands County. But it's a very active and very important still for farmers. They provide all kinds of services to farmers. Protecting the soil. Intensive tilling versus no-till. Let's look at these two things. So this is intensive tillage. You can see that the roots are kind of coming down to this one spot and they're kind of stopping. And you still have all this good soil down below. So what's happening here? Intensive tilling. Basically you take this top portion and you turn the previous season's growth under, but it stops. That's as deep as your plow goes right there in that surface. But the soil goes deeper. You know, talking about 20 inches. We have soil down to 72 inches actually in some places. You basically then dig those furrows in that bare soil and plant your seeds. Put those seeds in that bare earth. Yeah, that's what you're used to seeing. And then you have this, basically, if you will, a rock. See if I'll show up. The thing called a plow pan. It is basically, it stops. There's a compaction of the earth there. And that plow pan prevents the soil, the plants from getting down into these lower reaches and being able to actually access those micropores and the nutrients that are down there. So no-till, what's no-till all about? Well, long-term no-till, it doesn't happen right over time. You see there's a seed there, and there are roots going all through. And when I say no-till, well, don't get ahead of yourself. Leaves that organic cover. So you don't till, you don't take a plow and break all that stuff up. You plant the seedlings by drilling into the soil, drilling them in. That preserves this network of pores, sites of nutrient exchange that develop in the healthy soil over time. So you have all these pores, and you have a lot healthier crop from that. You have to have the right tools, but that's okay. So, some negative activities that soil conservation takes on. Overgrazing. We've seen this, and we'll see this in later chapters, where actually farmers have gotten together and said, hey, we need to work together to preserve our grasslands. A monoculture. Very important that not just rotating crops, but having rotational crops in the same field where you have a variety of crops. Overhead irrigation is one of those things that we have overcome tremendously here in this part of the world, where we no longer, if you used to drive through these orange groves, and all you would see is these big old standpipes with whirlybirds on them that were actually irrigating the land. And you don't see that anymore. You see other types of irrigation. Over-fertilization. Fertilizer costs money, something we don't really always appreciate, but farmers certainly appreciate that fertilizer always costs money, and if you fertilize too much, it's not going to actually go to benefit the plants, it's going to end up being washed into lakes. Kind of gets to me. Fire suppression. We no longer allow our fields to burn, and that when you burn a field, it releases a lot of nutrients naturally. And we've drained wetlands. Wetlands, you think, well, that's where you put the ag land. No, we need wetlands to help protect from flooding, because that's what they're there for. They flood rather than flooding other parts of the world. So the positive activities. Crop rotation, rotating crops from one type to another, restores the soil, a tremendously important thing to do. No-till. It's something you have to get the right equipment for, but if you're in growing a crop that requires that sort of planting, there are places where you have orchards and you don't have to worry about this. There are other issues you deal with. But no-till is very important in terms of protecting and actually improving crops over time. Got to maintain that plant cover when you're doing no-till to make sure you don't have the wind picking up the soil and carrying it away, because soil is the commodity. That's the thing you have to grow plants. Without that, you don't have a foundation for agriculture at all. Sustainable irrigation. There's this some ideas, particularly in citrus groves. We've gone to this drip microjet technology rather than having these stand pipes that stick up above the groves and you have the water spraying all over the place. We have microjet right at the base of each tree. Organic, sustainable fertilizer, using more manures and things like that to actually spread on the crops, is probably, if you can get it, if it's a rare thing, because we don't seem to be in the process of taking organic waste, there's plenty of it out there, and turning it into fertilizer. Instead, we tend to go after a lot of the petroleum sources for fertilizer. And then control burns. Agriculture, particularly in the southeast, has never really stopped doing control burns because they understand it's a lot easier if you want to clear your pasture to burn it off than to mow it or to overgraze it. Burning's important. Preserve wetlands. We need and we have expanded the use, particularly in Florida, Peninsula Florida. We use pastures for water storage in floodplains. And you think, well, you're flooding the pasture, you can't use it. Well, then the rainy season, it's a battle to keep the water out of there anyway. There are times when it's just better to go ahead and allow the pasture to flood, store that water, and then release it when it would naturally go down anyway. So, sustainable ag and the developing world is the next lecture. We look at inorganic versus organic fertilizers, ag self-sufficiency, and Swidden. I don't think that made this slide. I'll find out here in a minute. Sweden Ag. Talk about that. So, we talked about hunger, malnutrition, food supplies, and the environment. How our food supplies, they may not appear to be declining, but getting it to the right people at the right time is a real challenge. Feeding people versus protecting the planet, we need to do both, but we need to be good stewards of what we're doing. Soils are the foundation for, well, any agriculture, sustainable agriculture for certain. Talked about breaking up rock, taking that high nutrient big piece of rock and breaking into smaller pieces, physical, chemical, and biological processes. And the smaller the pieces, the greater the surface area and the more likely the plant is to be able to get to the nutrients in that rock. History of ag, we look at where coffee comes from, Ethiopia, and rice and potatoes and maize and sorghum. And hopefully you can go back and look at those slides and remember, oh, that's what he meant. Soil as an ecosystem. How long does it take to form an inch of soil? Depends on where you are, somewhere between decades and millennia. Tens of years to hundreds of years to thousands of years. Soil chemistry is complex. We looked at that briefly. The role of soil conservation, the Dust Bowl, and how we're still overcoming. We're going to continue. It's a continuous process. It won't end. Sustainable ag and developing world next time. Reminder, 1 inch of soil. What happened in the time it took to form 1 inch of soil? Don't forget this pop quiz. The time it took 1 inch of soil. Pop 10 quiz drop box. 3 things this poster says happened. Has to be on the poster. 7 a.m. by the last day of Unit 3. Please see the syllabus for when that date is. Don't be late. It won't be open for long. And this is 10 points extra credit for the unit tests. It's worth it, I think. These are the references. And I will leave you to contemplate those or other references throughout the lecture.